Let's take a look at this problem. We got y to the third equals 2 plus x to the fourth. And we want to find dy dx, we want to find our derivative with respect to x. The derivative of y with respect to x, I should say. So we'll take the derivative of everything where it's sitting. And we'll take it with respect to x. So I'll take the derivative of y to the third with respect to x. I'll take the derivative of 2 with respect to x. And I'll take the derivative of x to the fourth with respect to x. Well, if you got a y, you just take derivative just like normal. So y to a power, take your power, put it out in front, lower it by 1. But since you're taking the derivative with respect to x, and it's really y, we have to put on a y prime. Derivative of 2 is 0, so that drops away. Derivative of 4x to the fourth gives us 4x to the third. Now we want to end up solving for y prime, so that 0 doesn't do anything, so I can go ahead and drop it. There we go. Now we'll divide both sides by what's in front of our y prime. So we'll divide both sides by 3y squared. X to the third, 3y squared. When we do that, these 3's will cancel, the y squareds will cancel, and we got y prime is equal to 4x to the third over 3y squared. And that's our answer. Now, again, if I solve this for y, if I took the cube root of both sides, took both sides to 1/3 power, I would get y is equal to the cube root of 2 plus x to the fourth, or y is equal to 2 plus x to the fourth to the 1/3 power. This is one you could actually solve for y. Not all of these you can. Actually, most of them you can't. Well, this is the chain rule, the general power rule. We got parentheses to a power. So when we find our derivative, you take your power, put it out in front. What's inside your parentheses remains as is. You lower your power by 1. And then you multiply it times the derivative of what's inside the parentheses. So the derivative of 2 plus x to the fourth. Well, that's going to give us 1/3. And then we got 2 plus x to the fourth. 1/3 minus 1 is negative 2/3 times the derivative of 2 is 0, and derivative of x to the fourth is 4x to the third. Okay, so this 4x to the third I can put up on top. I'll put this all into a single fraction. So I got 4x to the third, and then down below I got 3 times 2 plus x to the fourth to the positive 2/3 power. Now you're sitting there looking at this maybe, and you're trying to figure out this answer here looks quite a bit different than what we came up with. I mean, it's got a 4 and a 3 and x to the third, but the rest of it's pretty bizarre. Well, remember our original. You don't have to do this, but our original problem looked like this: y to the third is equal to 2 plus x to the fourth. What I could do is solve that for y, which I did up above. So take both sides to 1/3 power, and we'd have 2 plus x to the fourth to the 1/3. We could then continue on with this, simplifying, put 4x to the third, and down below we'd have 3 times y squared. Well, y we just said was this, so let me plug that in. 2 plus x to the fourth to the 1/3 squared. Now when we do that, we got 4x to the third over 3. When you raise one exponent to another exponent, you multiply them together. 1/3 times 2 gives us 2/3. So we get 2 plus x to the fourth to the 2/3 power, which you can see then matches our other answer. So don't get really wound up if you work it like two different ways. You come up with answers that don't appear to be the same. If you did some simplification, again, you'd find out that they are the same.